You're fine. Okay, so when we're talking about projectile motion now, we talk about something that's either been launched and it'll have an angle, launching angle point, or we talk about it moving in either a linear or a angular direction. So linear, two-dimensional linear, we just did. It's just a matter of going through everything and doing what you need to do. When we have a launch angle, that changes what and how you figure this out, because you now need to use the right triangle and you need to use trigonomic functions to be able to figure out what the sides are. All right, so looking at number 1 here, it's during a fireworks display. A shell is shot into the air with an initial speed of 97.8 meters per second at an angle of 68 degrees above the horizontal. The fuse is timed to ignite the shell as it reaches its highest point above the ground. Draw the diagram and complete the XY chart. So we're going to look at this 2 ways. You can do this as a situation. You can do this as you can have it go up and come back down, or you can just figure it out doing it. It's just going up to the top. I'm going to do it that it goes up and comes back down, and then you take the half of each one of those, and that's going to tell you how high the actual shell is. All right, so when we're looking at the XY chart, it's going to be tough. VIX, VFX, A, T, and D of X. D of Y, T, A, V, F, Y, B, F, no, P, I, Y. Okay. So again, we take into account what we know. So when something is in free fall, it's a -9, or something's in the air, it's -9.8 meters per second squared every time. Acceleration on the x-axis is going to be 0. All right. Other than that, we don't know anything. So let's draw our diagram. So it gets firework, gets launched at a 68 degrees above the horizontal. Okay, so this is 68 degrees. Highest point. Draw that. Hypotenuse to there. So you note this is 90 degrees. Okay, and when we talk about right triangles, this is the hypotenuse. This is the angle you're measuring off of, so this has to be the adjacent, and this is the opposite side. And also keep in mind, when we do our trig functions, it's sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So, katoa. Okay, so that's that. But I will always give you guys what the trig functions are on any assessments or any quizzes, so that way you have it. Okay, so the thing that we know is the launch angle is 68 degrees. Is 68 degrees. We also know the initial velocity is 97.8 meters per second, but because it's launched on an angle, we can't say yes, that's X, or yes, that's Y. So we have to put 97.8 meters per second here. And now we can try to figure out opposite side, adjacent side. Okay, and you're going to need to know and have a calculator. That's going to be able to tell you what the sign of a number is, and it's going to be a four-digit number. So I just want to say, not that. All right, hold on 1 second. Let's pause this for a second. Okay, so if we're going to try to find out the numbers, we have to figure out, okay, what is the launch angle, which we already know is 68 degrees. So the sine of 68 degrees equals the opposite side over the hypotenuse. So the sine of 68 degrees equals the opposite over the hypotenuse, which is this, it's 97.8. Okay, so, and when you put in your calculator, you hit sine 68 equals, it gives you a decimal. In this case, it's 9272. You only have to go 4 spots. All right, which equals the opposite over 97.8. Well, cross multiply, and that gives you what the opposite side is. So opposite's going to equal which is 90.68 meters per second. So that tells you that this side is 90.68 meters per second. Now, at this point, you have 2 options to get the adjacent side. You can either do Pythagorean theorem, square both of these, and then take the square root and go from there. Or you could just do, to solve for adjacent, you can just do cosine of 68 degrees, which is what we just did. So cosine of 68 equals adjacent over hypotenuse. Okay, and then so cosine of 68 equals.
You could, and you just pretend.
Adjacent over 97.8. The 4 digits, it's 0.3746 equals adjacent over 97.8. And again, you're going to multiply 97.8 by that 4-digit number. .3746. 97.8. And that's going to equal 36.64 meters per second. And that's the adjacent side. Okay, so a couple things that you can see here. This is obviously the opposite side is a vertical side. So that should give you a clue as to where those meters per second will go. And then the adjacent side is a horizontal side. So again, that's going to give you an idea of which way that is. So the adjacent side gives you the initial velocity of 30.64 meters per second on the x side, which means it's also the final velocity on the x side because there's no acceleration taking place on the x side. This is 90.68. That's your initial velocity as the firework goes up. The fuse is timed to ignite the shell just as it reaches its highest point above the ground. Draw the diagram and complete the XY chart. So this is where you could do it 2 ways. You could say it's going to go up and come all the way back down, and then you would make the final velocity of y be the exact opposite of what it is as the initial velocity. However, in this case, what we could do is just make the final velocity 0, because when you make the final velocity 0, that means it's reached its apex, and that's when ultimately it is supposed to explode. Okay? So we can figure out how long it's going to take to be able to do that by using the kinematic equations. All right, so the kinematic equations VF equals VI times A times T. VF equals VI plus A times T. We're going to use the Y values to figure out the time. Remember, the time is for both. So VF equals 90. VI is 90.68 plus a negative 9.8 times T. Negative 90.68, you subtract it from both sides. Negative 9.8 T, divide both sides by negative 9.8. And your time equals Seriously? So 90.68 divided by 9.8 equals 9.25 seconds. So that's your time on both sides, and that's for it to reach the apex, so it reaches its highest point. So now you can solve for the distances for it to explode. So in this case, what I would do is to figure out the y distance, d equals VIY plus VFY over 2 times time, d equals 90.68 divided by 2 times 9.25. D is going to equal 45.34 times 9.25. The displacement of y is 419.40 meters. So 419.40 meters. Okay. And then to figure out how far it went on X, you can do the same thing, but in this case, it's going to be D equals 36.64 times 9.2. Because when you divide by 2, it's the same, this is the same value, these are the same values, so you just take it out, and it's 36.64. D of X equals 9.25. All right, so your X value is 388.92 meters. That's how far that has traveled. And then it explodes at the top. Now, follow-up questions could be, how far, if the shell does not explode, so some follow-up questions would be, if the shell does not explode, so if the shell does not explode, some follow-up questions on this are, how long was it in the air? Well, if you know for sure that this number, that 9.25 for time, you know that to go up to its highest point is 9.25. If it takes that long to get up to that highest point, for it to come back down to where it started, all you have to do is double it. So in terms of that, this is going to be 18.50 seconds. Okay. Its X displacement is, well, if it traveled this far in 9.25 seconds, again, you're just going to be doubling this number here, and it's going to be 338.92 times 2. So it's going to be 48776. So it's 600. So the displacement on the x-axis is 677.84 meters. Now, what's your displacement on the y-axis? So it goes up 419.40 meters. It's supposed to explode, but it doesn't. Now it's got to come back down. What is the displacement of y? The displacement of y is going to be 0 because it came back down. What's the distance? So you could ask another follow-up question. What is the distance the shell travels? So if you're asking that question because it's distance and distance is always positive, then you can just double it. It's 419.4 times 2. So it's 8, 8, 3, 8. So in that case, it's 838.80 meters. Okay. And one final follow-up question. What would be the final velocity right before it hits the ground coming back down? Remember, this isn't going to change. X's are going to stay. This can change because it's coming back down. Well, what goes up must come down, and it's going up at the same rate. It'll come down at the same rate it went up. So really, VFY would be a negative 90.68 meters per second. So that's how you do this type of question.